Welcome back to the MSU Deer Labs online seminar series. It is brought to you by the Mississippi State University Extension Service as well as the MSU Forest and Wildlife Research Center. I will be your presenter today. My name is Bronson Strickland, and I want to acknowledge my colleague and the co-director of the MSU Deer Lab, Steve Damaris. As the name implies, this presentation is all about cool season food plots. Want to review everything more or less that we've learned over the past 10 or 15 years. Want to go over the most common forages, their nutrient profiles, which plants work well, which ones work well in mixes, and which ones deer are attracted to. When we're finished with the presentation, my goal is that you are going to feel completely equipped to know what to plant on your property and why. By no means is this every possible thing you could write about or talk about with cool season food plots, but I think it's a really good collection, certainly for people starting out to get you going. Okay, now I want to shift gears and review plant biomass production and quality, and let's make some comparisons there. Okay, we'll start with cereal grain forage biomass production, and this is from our data from our agronomist at Mississippi State from variety trials for 2011 to 2019 from 4 different locations throughout the state, from north to south Mississippi. And I wanted to use these data rather than data from test plots I have done, just because I wanted to get as much variation, regional variation as possible, and as many years as possible, so that I could provide you all with as reliable of an estimate as possible. What you see there, the bar chart in red, that is the average. The error bar, point towards it here. So this value is going to represent the average, and then this would be the minimum value, and that would be the maximum value recorded over these sites and over these years. So we left off a few slides ago with ryegrass, so let's go talk about one of the good properties of ryegrass. It produces a lot of forage. So in terms of the good I was talking about with ryegrass is that, yeah, there is no denying it. It is in Mississippi anyway, during this period of research, it produced about double the amount of biomass. So approaching 6,000 pounds per acre of dry matter. We see that probably not a significant difference, and not even a meaningful difference in my opinion for the others. They're all going to be somewhere between 2,500 and 3,000 pounds per acre between rye, oats, and wheat. And you can see the variability, for example, with oats. Kind of amazing. There was one site in one year, it too approached 6,000 pounds per acre. So there can be a lot of variability, as you might imagine. Was it a really dry year, a really wet year? Did it turn really cold really quick, or was it really mild? All that is going to affect the growth and yield of these forages. So that just gives you a good idea of the amount of biomass you can expect from these forages. So similar format here, but now for clover forage biomass production. Notice we're talking about, they're all good. They're all really, really good. I think distinguishing which clover is more appropriate for you, again, is going to depend more on the timing of when you want that production, and we'll deal with that more a little bit later. But it's all in when the clover is going to mature, how long it's going to persist, things like that. Because you look at red, berseem, balança, arrowleaf, crimson, I mean, they're all over 4,000 pounds per acre. Remember the cereal grains, the oats, wheat, and rye was right around 2,500. And these clovers are producing over 4,000. The one that's a little bit less on the average is white clover, but that's still 3,500 pounds per acre. That is a lot of clover biomass. And now plant quality, and I'm measuring that by crude protein, and same format with the average, minimum, and maximum. These data are from one particular site over a number of years, so always use caution there. You may get a different value on another property, but these are the ones I was able to collect on a property research site that I work with. So we have crude protein. All of the cereal grains, including ryegrass, are all over 10%. And we see the minimum and the maximum. Some of these maximums, you know, for rye and oats, and look at oats at one time, 22, 23% crude protein. So depending on the time of the year that it was collected, was it actively growing or was it beginning to slow down? And we certainly know towards the end of their growth cycle, the cereal grains, the crude protein and quality is gonna drop significantly. So this would be at the time of year when they're growing and when deer are selecting them and using them. So we're not going to have those clover values of protein for throughout the growth cycle of the cereal grains, but for part of the year we're pretty close. And now crude protein values for clover: Durana white clover, Ladino white, arrowleaf red, Balanza, Berseem. We're again talking about levels of good, levels of really good. In this case, and again I want to qualify, this is from a particular site and a few years. You could get values a little bit different on your site, but yeah, the consistent champion here was Durana white clover. Not only in that it averaged 20%, but there was just very little variability in that. Notice it just about always was had about 20% crude protein. All the others, we see the Ladino white, arrowleaf red, Balanza, they're all above the average, above 15%. And then it just depends on the time of the year when the sample was collected. Some of these over 25%. Crimson on our site didn't yield as much crude protein value, but again, there were times when crimson was provided 20% crude protein. So this is what's so beneficial, whether you're planting within the plot a mix or whether you have a mixture of different plots. But having a diversity of clovers, I think it just buffers you against these growth cycles, and having some white clover in places, having other clovers, annual clovers in places, they're all going to be really good. And it really just comes down to some of them are probably going to be better or a little bit higher quality during certain times of the year. But again, they're all really good. And some of the other forages: crude protein, Austrian winter peas, turnips, dwarf Essex rape. Notice again, in terms of just on the average, the Austrian winter pea was a little bit better, somewhere between, on average, between 15 and 20%. But there were times of the year where it was over 25%. Turnips, surprisingly, there were times where it was above 20% with an average of about 15, and rape just a little bit less, averaging 14%. So again, all of them, that's the reason they're used for deer food plot forages. They're all really good in terms of biomass production and quality. So now let's review forage biomass over time, and what I mean by that is just the dynamics of growth and how much forage is going to be available to deer throughout the growing season. Okay, so now let's look at the growth patterns, or how it changes over time. And notice here on the x-axis, we're going from February until June. And notice we have very relatively little forage biomass on these plots that were on a particular property. And if you're wondering why I don't have each line labeled for species, I just didn't want people, including myself, to pay too much attention to the species when we're only using data from one site over a couple years. Again, different site, different series of years, you might have a different result. What I think is important is that we're looking at the characteristics of the cereal grains and how they perform. So notice in the cold of winter in February, not that much growth, not that much yield at that time. Same thing for March. And we see this rapid growth, and that is when they're going to seed later in the spring, April and into May. So a lot of growth at that point, and then shortly thereafter, they're going to senesce and die. So a very typical growth curve for your cereal grains. Same graph, just a different way to look at it. Just smoothed some of the noise with all the different lines and took the average here. So exact same relationship. We just see this really big peak in May or in springtime, and then we see a rapid decline soon thereafter. And now the clover biomass over time. Same reasoning for not labeling each of the lines. Just wanted to look at the general relationship, and we see that in the cold of winter, the dead of winter, it varies a little bit by species, but we have very little biomass production then on into March. And then as the air temperature warms up and then soil temperature warms up, that is when we see that explosion of growth with clover into April, and as you can see here, into May. And then again, depending on species, maturation date of the species, etc., we can see a lot of production even into June and the end of June. So there is your general growth and yield relationship for clover forage biomass. Same here, just cleaned it up to show the average. You'll see the really big peak in May. April's not on the graph, but April would be included. And this is the average here all the way until June. Again, individually, some species more, some species less, but on the average, we see still strong production into June with a lot of our clovers. And when you overlay those relationships, you get the following. So you can see more forage production from the cereal grains during the winter. Then we see both of them increase rapidly into April and May, and then a more sharp decline with the cereal grains. Now what I'm going to go to in the upcoming slides is don't be influenced here too much by the forage biomass of the cereal grains, because in this graph I'm not including quality. So we'll talk about that more in a moment. But this is in terms of the biomass you see in the field, this is the relationship. So now the other half of the equation, it's not just the biomass of a forage that makes it good, but also the quality. So we'll examine the quality and how it changes over time next. So another rather messy graph here with a lot of different lines, but I included this again just to show you there is individual variation in these species, but they're all relatively high. Notice during March and into May, most of them are well over 16%. And then for 2 to 3 months, they're going to be holding that value. And then most of them, as they have gone to seed and begin to die, of course, the crude protein is going to drop. Some of those are going to hold their protein value longer just because they're maturing later. But that is the collection of the clovers we sampled. That's the relationship we see. And I'll show you the average next. So a simplified version here, we see the peak in the March sampling period, the May sampling period, really no decline at all in between there. And then we see the decline on average till about 14%, give or take, depending on species, in June. So what is the forage quality of the cereal grains over time? Well, it's a little bit different story. Remember, we had the spike in biomass production in March and in May that looked really, really impressive. But at the same time, the forage quality is low and is decreasing. So even though it looks like there is a lot of cereal grain biomass out there, the deer aren't eating it. And probably the very reason you are seeing it that is so conspicuous and tall is because the quality is really low. The deer are not eating it and instead shifting to the clovers for forage. If we put those lines together, that is indeed what we see. They start at a very similar place in the wintertime. So the cereal grain is going to have more biomass in winter, clover far less biomass, and similar quality. But we see a complete shift in that when we get into March and April and May. They may have similar biomass at that point, but the quality is much, much lower. So starting in about April, maybe sooner, a little bit later, depending on where you're at, but that is the time for clover production, and that is when its quality is at its greatest. And now we have really extended 3 to 4 months of forage production, quality forage production, to feed deer. So we have really widened the window for how long that one single planting we do in the fall can produce quality forage for deer.